Hello everyone, welcome back to our intensive physics virtual lessons. Super excited to be back doing this after our break. We're going to be continuing in chapter 20 with some practice problems. We're going to divide it up into two videos, okay? So we'll do one practice problem in this video and then we'll do two in the next video. Before we dig into that, I just want to make sure that we have some concepts under our belt before we begin. You know, we always hear the term opposites attract, and when it comes to charges, that is absolutely true. You know, if we have a sphere with a negative charge and one with a positive charge, the force is going to bring them together. But if we have charges that are the same type, so both positive or both negative, they're going to repel, right? They're not going to be attracted to each other, and they're going to go off in opposite directions. And so that's going to be important when we solve our problems. Of course, we are familiar with we're going to be familiar with Coulomb's law. Our equation is given here. I know it's kind of crudely written out, but K is equal to Q1 times Q2 all over R squared. And we are solving for force in newtons there. And remember, our constant K is equal to 9 times 10 to the 9th, and we have our units here, newtons times meters squared all over coulomb squared. You don't need to include the units when we plug in for K. Now, one thing that you'll notice when we go over these problems is some of the values, they may not be given to you in meters, or they may not be given to you in coulombs. Instead, we might have to look at things like centimeters, microcoulombs. And so if you don't know your SI prefixes, I'm going to recommend that you either take a look at your resources online or in the book to make sure that you're getting all of this information. Okay, one thing in particular that we're going to see a lot is the letter mu, right? The Greek letter that basically says, from our base unit, it's going to be multiplied times 10 to the negative 6. So stay tuned for that. Okay. In our first problem, I'm doing something a little different with our problems here. Okay. We have two spheres that are 10 centimeters apart. One has a charge of 6.0 microcoulombs, and the other has a charge of -3 microcoulombs. What is the force between them? And so I put the question on the bottom to save a little bit of space. I'm going to show you what I'm going to do here. I'm going to go ahead and write my knowns. And so I can see that they're 10 centimeters apart. So R is going to be 10 centimeters, right? The one sphere has a charge of 6 microcoulombs. I'll put the decimal in. Okay, and the other has a charge of -3 microcoulombs. And we want to know what the force is in between them. Okay, so I have my knowns. I'm going to get rid of the question. Actually, I'll draw a little picture. So here we have 6 microcoulombs. Okay, and then over here, we've got -3 microcoulombs. Right, in between them, we've got 10 centimeters. Okay. And I'm going to get rid of this question here so that we have room to work. All right? And the question's asking us, what is the force? All right, so I'm going to go ahead. I'm going to draw out my Coulomb's law equation. Q1 times Q2 all over R squared. Okay? And so when we go ahead, we can we've got a lot of information here, right? We've got a nice picture, we've got our givens. we can look at this and say, yep, we've got a value for R. Yep, we've got a value for Q1 and Q2. Let's just go ahead and substitute everything in. And I just want to make sure that you understand kind of how to plug things in so that we end up getting the right answer. For starters, we need to put everything into this equation in terms of not centimeters, but meters. Okay, so the first thing I need to do is convert 10 centimeters to meters, and you get 0.1 meters. Okay, so that's important. Always have to substitute meters in for R. Can't be centimeters. Okay, the other thing we need to do is we need to express Q1 and Q2 in terms of coulombs. And so remember back when I showed you those SI prefixes, we can actually rewrite this as, I'll write it just underneath here, 6.0 times 10 to the negative 6 coulombs. Okay, I can do the same thing down here. Q2 is going to be equal to negative 3.0 times 10 to the negative 6 coulombs. Okay, so we just went from microcoulombs to coulombs. Okay, and so we just have to remember that our prefixes are in there, so we need to get everything in terms of coulombs to substitute. Now, the other thing we want to think about, we have a negative value here. And so you might be tempted to put that negative value in for Q2. The negative only tells us, the negative and the positive in any problem, only tells us where the force is between the objects, okay? So because we have opposites, remember opposites attract, the force is going to pull them towards each other, okay? Once we establish that, we actually can get rid of the negative. The negative doesn't really matter anymore, okay? We can actually take the absolute value of this and substitute it into our equation. And I'll show you how to do that now. Okay, I'm going to take 6.0 times 10 to the negative 6 coulombs times positive 3.0 times 10 to the negative 6 coulombs, right? Remember, the negative was just here to tell me in which direction the force was going in between those two objects, okay? I put in a positive value regardless of whether this is positive or negative, and I take all of that over 0.1 meter squared, okay? And so then I can actually go ahead and solve for F. When you do that, you get around 32.4 newtons. Okay, and I go ahead and I circle my answer. Remember, we're still solving for force here. Okay, so our units are still going to be newtons. And so what we're actually finding is this vector here, this force vector here, there's actually 32.4 newtons between the two charges. Thank you for tuning in. We're going to have another video that's going to go over 2 more example problems. If you have any questions, feel free to put your responses in that Google Doc sheet. Or if you can't get a response there, please email me. Have a great day.